Hello everyone, welcome to our YouTube channel Code Till Login, which self-explains that you should code every day until you reach the stage where you can write your code in login time without using Google. And even after that, you should celebrate but always keep moving forward. Happy coding! So let's begin with the session. Welcome to Code Till Login. So today we will see how to find prime factorization of a given number n. So we'll see it through three approaches. So we'll see naive approach, we'll see optimized approach of this, and then we'll see the sieve-based approach. So we all know how to find the prime factors of a given number. So if I have number 24, its prime factorization is 2 cross 2 cross 2 cross 3. So what is the basic funda behind finding this prime factorization? So what we are doing here is we are just dividing a number n with the smallest prime number which can divide our number. And we divide with our smallest prime number repeatedly until it doesn't divide it. For example, here our number is 24, so we'll see through the smallest prime number, which is 2. So we'll see if 2 can divide 24. So 2 can divide 24, so we mark 2 as its prime factor, and then we repeatedly divide it by 2 until it doesn't divide my number. So after we had divided it by 2, we get 24. Earlier I have 24. When I divided it by 2, I get 12. And then I again divided it by 2, I get 6. And then again I divided it by 2 until my number is divisible by my smallest prime number. I will divide it by through that small prime number only. I will increase my prime number by 1 or by next prime number only when it is not divisible by my current smallest prime number. So here I get 3. Now I see that 3 is not divisible by 2. Now I come to the next prime number, which is 3. So I divide my number by 3 and it is 1. So my prime factorization is 2 cross 2 cross 2 cross 3. So let's see, this is the quite optimized approach. Let's see how we can do it in the naive approach. So in the naive approach, what I need to do is I will go through every number before n, and here what I'll see, if my n is divisible by 0 and if my n is divisible by 0, I will repeatedly divide it by that I only until it divides my n. So until my n is divisible by this I will repeatedly divide it by I only. So this is a pseudo code of my how to find the naive approach of how to find my prime factorization through a naive approach, through a general approach. Now let's see how we can modify this a little bit. So how I can modify it, let's see, let it be the same. What I need to change in the optimized approaches, I just need to go through routing. So this will, and one more thing, if here I get I not equals to 1. Sorry, n after multiple divisions, if I don't get n not equals to 1, then this n is a prime number, which is also added into my prime factorization. So I just need to go through square root of n and it will automatically calculate my another factor. Now let's see what's there in the C based approach. Before this, let's see how we can implement this optimized approach through our code. So let's create a function first. So this is my function to print prime factors of my number n. And what I'll make here is I'll make a vector of pair of int comma int of factors. So this will store the prime number with which my number is divisible, and this int will store the number of times this my current prime number is repeated. So I'll maintain a count to check how many times my particular prime number is getting repeated. Now going through my loop from I equals to 2, I cross I less than equals to n, and I plus plus. So I need to check if my number is divisible by I. What we'll do here is we keep on dividing it by I till it is divisible. So I'll initialize first count equals to 0 and I'll keep dividing my number. I'll first check if it is divisible, then I'll keep dividing my number by n, and then I'll count this. What I need to do next is I need to push in my vector make pair I comma count. So then I'll check now if my n is not equals to 1 after dividing so many prime numbers before n. So whatever is left is a prime number. Okay. So factors dot push back make pair n comma 1. Got this? Now what I need to do here is I just need to print my factors. Further I need to print p first, then raised to the power p dot second. Now what we need to do is call out this function in main. So I'll take n, I'll take input from the user and then call print factor. to it and return 0. Save it and run. So let's see if I enter 24, what's down. So it's 2 raised to the power 3 and 3 into 1. So as we have seen, the prime factorization of 24 is 2 raised to the power 3 and 3 is raised to the power 1. So this is going to be correct. Let's enter one more number. Let's enter 8. So it's 2 raised to the power 3, which is working perfect. Now let's see how to implement sieve-based approach. Now coming to sieve-based approach. So far what we are doing is we are going through either from 2 to root m or going through every number before our n. So what we are going to do in sieve-based approach, as you can see, the prime factorization of my number only contains prime numbers. So what we are going to do in sieve-based approach, we'll only check if my number is divisible by or not with only prime numbers. I will not check with any other composite number, because any other composite number, for example 6, has to be decomposed into 2 and 3 separately. So why do I need to check for 6? Because it has already been covered by 2 and 3. So in sieve-based approach, it is useful when you have a number of queries and you need to calculate lots of values of prime factorization of n. So what we are going to do here is we'll calculate it by using the function. Let's see here. If I make void factorize, this I give int m and so here m is the number of which I need to calculate the prime factorization, and primes is the vector of integers which only contains prime numbers, like we have calculated sieve in the last lecture. So what we do here is we maintain a vector array which contains all the factors. What I do here is factors appear. Now starting from int I is equals to 0 and p equals to I check from the lowest prime number. While p cross p less than equals to m. I'll check through the square root of m. So if my number m is divisible by this p, then what I need to do is I need to push this p, this prime number inside my factors vector. And now I'll check if it further divides my number, then I'll keep on dividing it with p. After this, I'll go to the next position and make my next prime number as after checking through all the prime numbers, now still If my m is not equals to 1, this means that our m, the lifted n is our prime number. So we push m in it and I'll return my complete factors. So what we'll do here is we pre-compute the sieve of numbers only containing the prime numbers until a particular n. So let this n is equals to, and I'll create a vector which contains if the number is prime or not. What I will now is I will create a sieve through this function which I calculate in 5 minutes. So before this, what can we do now? For y equals to 0, y less than n, plus plus, and I need to initialize my every prime number with, I need to initialize my every number with false. I'll say first that none of them are prime numbers and will make it true through my functions. Then I'll take the number of test cases from the user. Now going through each test case, what we'll do here is take the number, now calculate all the factors of this number using the function factorize, in which I'll pass number on my primes C. Now I print all my factors. And then we'll return C. That's it. So what we need to do now is we just need to make our prime C function, which we have learned already in our previous class. So let's see. So let's create it first. What we need to do first is first mark all the odd numbers as prime. As it's all pretty obvious that we need not to check for any even number, because every even number will be divisible by 2, so it will not be prime at any case. So we'll check for only odd numbers. So first let's make all of my odd numbers as prime by initializing it with 1. Now let's create a sieve in this. If the current number is not marked, so it is prime. If P of I equals to 1. Then we need to mark all the multiples of I as not prime. For this, what I need to do is, for j equals to I cross I, j is then equals to j equals to j plus I. And this, what I'll mark them as not prime by making initializing it with 0. Now what I need to do, we have to mark our special cases also. Special case in which we need to mark our special cases also. In which special case P of 2 equals to 1 and P of 1 equals to P of 0 equals to 0. Now we just need to add our number which are prime to our primes vector and return it. For I less than I plus this, if this P of I equals to 1 means if it is a prime number, then primes shall push back and just return primes. Now just run and check it. You will check and see our prime numbers are calculated. Our prime factorization of a number is calculated in very less time. So we'll meet in the next lecture. So we'll meet in the next session. Until then, code this, practice it, and happy coding.